This video shows how MySep-RunTime makes process simulations more representative to help avoid design flaws and mitigate the risk of operating issues. MySep-RunTime adds reliable separator performance calculations to steady state and dynamic simulations. It calculates liquid and gas carryover, pressure drop, and also provides warnings when the operating conditions exceed the capabilities of the vessel and internals design. All the calculations are done based on the actual vessel design geometries that you import from file. Let us take a look at how separators are commonly simulated. They are typically assumed to be 100% efficient. This assumption of zero carryover, however, is unrealistic. In practice, in the field, vessels are not 100% efficient and there will be carryover. This carryover impacts the operation of downstream equipment, for example, heat exchanger duty, vessel separation performance, compressor operation, and sales gas hydrocarbon dew point. We will now run this dynamic simulation and compare the zero carryover assumption with the calculated carryover using MySep-RunTime. The simulation is currently being run with the assumption of zero carryover from the vessels. The strip chart shows the hydrocarbon dew point of the export gas. The dew point is around -11 degrees Celsius. The specification is -10 degrees Celsius, so all appears fine. Now we activate the MySep-RunTime and the actual performance and carryover from the vessels is taken into account in the simulation. The dew point increases to about -8 degrees Celsius, which does not meet specification. So, if the engineer uses MySep-RunTime, he can see and address this dew point issue at design time. Without it, the issue is not visible at design time, but will become apparent upon startup of the facility. In such a situation, the plant throughput would need to be reduced in order to meet the dew point specification and prevent pipeline hydrates. We can simulate this by closing the export valve. We see that as a result of the reduced throughput, the carryover from the low temperature separator reduces, as does the dew point. Here, the plant gas throughput would need to have been reduced by 10% in order to meet the dew point specification. Carryover also affects the duty of heat exchangers. The strip chart shows the duty of the heat exchanger that cools the gas from the first stage separator. At the moment, the simulation is run with the assumption that there is no carryover from that vessel. If we activate MySep-RunTime, we see the increased cooling duty that is required due to the liquid carryover in the gas stream. Here we are looking at the gas outlet stream from the suction scrubber and the first stage compressor discharge stream. With the assumption of zero carryover from the suction scrubber, all looks fine. When we include for the vessel performance by activating MySep-RunTime, we see the carryover from the scrubber, but we also see that there is free liquid in the compressor discharge line. This of course is an indicator that compressor issues are likely to occur in the field. Now the engineer can take measures at design time and prevent costly downtime. A white paper with more details on this topic is available for download in the download section at mysep.com. To summarize, in this video we have seen that the common assumption of 100% efficient vessels in simulations can have significant and costly consequences. MySep-RunTime makes process simulations more representative, providing engineers with deeper insights and ultimately preventing design and operating issues. MySep-RunTime can be used in all stages of a project, during the design stages, debottlenecking, evaluation of future operating conditions, and system optimization. If you would like to know more about the benefits and capabilities of MySep and MySep-RunTime, please visit our website or email us. Thank you for watching.